This is section R.7, radical notation and rational exponents. A number c is said to be square root of a if c square is equals to a. For example, let's take a number, okay, 4, and the square of 4 is equals to 16. We all know that the square of 4 is 16, right? So if this is the case, then we call c, so our c is 4, okay, we call our c, so this is our c, so we call this 4 as a square root of this a, 16, right? 4 is the square root of 16. Similarly, we know square of 7 is 49, okay. Here our 7, okay, this 7 is the square root of 49, okay. Similarly, we have a number c, which is a cube root of a if cube of c is equals to a. The example, let's take, we have 2 cube and cube of 2 is equals to 8. So here 2, okay, so we have 2, this 2 is a cube root of this number 8. Now in general, okay, in general we call, okay, in general c, any number, is said to be nth root of a if c to the power of n a is equals to a. Like for example, we know 2 to the power 5. So what is 2 to the power 5 equals to? So this is 2 times to 4, 4 times to 8, times to 16, times to 32, right? So 2 to the power 5 is 32. So here 2 is the fifth root, okay? 2 is the fifth root of 32. So if you find the fifth root of 32, we get 2. Now, so here let's talk about the radical expression. See, here we have our radical symbol. So this is our radical symbol, okay, and so this is the square root, right? In general, this is the square root. So we have n here, which we call the index, and whatever we have under the radical is the radicand. So this is our radicals, okay, radical symbol, okay. This n is the index, n is the index, and whatever you have under the radical sign, that is radicand. If we are talking about the square root, okay, let's take an example. So we have a square root of 4. Now for this radical expression, our index is, so we compare our definition. So this is our definition. We compare our definition, this definition, nth root of a and square root of 4. So if we compare, what we can find, I'm like, for n, what do we have? We know this is a square root. So, and the square root has the index 2, okay. So we have index 2 here, but we do not write in general. So if you write, it's not wrong. In general, the index for the square root we do not write, okay. So if you have a square root, your index is 2, okay. So your index is 2, this is the radical symbol, and whatever you have under the radical symbol, we have 4, and 4 is the radicand, okay. Similarly, if we have fifth root of 5x cubed in this radical expression, this is our radical symbol, this is our index, we have n, and whatever you have under the radical sign, this is your radicand, okay. Now let's do some examples. So here we have to simplify each of the following radical expression. So we have a square root of 36. Is, you all know, square root of 36 is 6, right? Now here what we can do is that the square root of 36, we can rewrite this as we have a square root, and 36 is 6 times 6, right? We all agree 36 is 6 times 6, okay? And this is, so we have a square root as it is 6 times 6. We can rewrite this as a 6 square, okay? 6 has been multiplied 2 times, so we have 6 square. Now here the index for this radical expression is 2, so the index is 2, okay, and the exponent of this radicand is 2. So we have index 2 and the exponent of the radicand is 2. If you have this, then we get rid of our radical sign. So if the index and the exponent of radicand is same, then there is no more radical sign. So we have 6. So here it means you can cancel this exponent of radicand and the radical sign. And the only condition is that the index has to be equal to the exponent of the radicand. The next we have a negative square root of 36 is pretty similar to number A. The only difference is that we have negative outside of the radical expression. So we have negative as it is, and 36 is our 6 square. Now if we compare the index is again 2, okay, the index is 2, okay, and the exponent is 2, so we can cancel this and we are left with negative in the front and 6, so negative 6. This is our final answer. In number C, we have cube root of negative 8. Now what is negative 8 equals to? How can we rewrite negative 8? So negative 8, it is negative 2 time negative 2 time negative 2. So this is negative 2 to the power cube. So let's replace our negative 8 by cube of negative 2. So we have a cube root and we have negative 2 to the power cube for negative 8. Now, do we have the index same as the exponent of the radicand? So this is our radicand, okay, this is our index, this is the exponent of radicand, and these two are the same number, so we can cancel this and we are left with negative 2 as our final answer. Now let's go to number D. In number D we have the fifth root, okay, the index is 5 and this is our radicand. Now let's simplify. So 32, so let's see what is 32 equals to. 32 is 2 times 2 times 2 times 2 times 2. So the fifth power of 2 is 32, right? And we have 243, and 243 is 3 to the power 5. So if you multiply 3 5 times, we get 243. Okay, this is 243. Now let's replace these numbers with their exponent. So we have the fifth root, and 32 is 2 to the power 5. 243 is 3 to the power 5. Okay. Next, now if we compare our numerator and denominator, so this is our numerator and this is our denominator, and both of these have a same exponent 5. So this is the exponent 5, this is the exponent 5. So we can rewrite this. So we have the fifth root, so we can rewrite this as a 2 over 3 to the power 5. Okay, now here the index is 5, this is our radicand, and its exponent is 5. Now we can cancel this fifth root and fifth power. We are left with 2 over 3. So this is our final answer. Now next we have the fourth root of negative 16. Now let's try if we can rewrite a negative 16 as exponent of some number. We know negative 16 is, okay, negative 2 times negative 2 times negative 2 times 2, right? Because negative 2 times negative 2, positive 4 times 2, that is negative 8 times 2, negative 16. So here we have 3 negative 2, so we have negative 2 to the power cube times 2. So here we have the fourth root, and we have negative 2 to the power cube times 2. Now here we have this radicand, and each of this radicand, they don't have the exponent same as the index, so we can't cancel. There's nothing we can cancel, right? Okay, now so there's nothing we can cancel. So what next? Can we find the fourth root of negative 16? Now in this case, so if you have an even index and you have a negative, then in that case we will not get the real number. Okay, we can express the fourth root of negative 16 as a complex number, and we will be talking about complex number in our first chapter. But right now the fourth root of negative 16 is not a real number. Okay, so let's write down our final answer as not real number. And the only reason is that if you compare number E with number C, the difference is that in number C we have the odd index. Okay, in number C we have the odd index. Okay, in number E we have the even index. So if you have the even index and negative radicand, then that number does not have any real answer. Okay, but we can always rewrite that in a complex number. So these are complex number. So now let's talk about some of the properties of the radical. Okay, now as we have seen in our examples, if n is even, so n here is the index, so if n is even, then nth root of a to the power n is absolute value of a. So we have even index, let's take, we have 4, okay, and we have, let's say, 5 to the power 4. The index is 4, which is even. Okay, and index and the exponent of this radicand is same, so we can cancel this, and this is equals to absolute value of this number, which is 5, and the absolute value of 5 is simply 5. Similarly, if we have, okay, 6th root of negative 2 to the power 6. Now here the index is even, and the index is same as the exponent of radicand. Okay, so we can cancel this 2, and this is absolute value of negative 2, and absolute value of negative 2 is positive 2. So if your index is even, then nth root of a to the power n is absolute value of a. Now what if it's odd? So if the index is odd, if the index n is odd, then nth root of a to the power n is simply equals to a. Example, so we have cube root of negative 2 to the power cube. Okay, the index is odd and the index is same as the exponent, so these two cancel, and this is equals to not absolute value of 2. Okay, this is equals to negative 2. There is no absolute value if we have the odd index. If it's the even index, then we have the absolute value. If it's odd, then there is no absolute value. The next property, if we have the same index, then we can multiply our radicand together. Okay, so we have the same index and we can multiply our radicand together. So here let's take, we have, okay, Okay, I'm trying to change my highlighter into a pen, and okay, now here I can see it. Okay, let me erase this. Okay, so where we were, yes, so we were at the multiplication of radical expression, and when we are multiplying we must have the same index so that we can multiply the radicand. For example, let's take an example. We have the cube root of 2 times cube root of 5. So here the index is same, so we can multiply our radicand. So this is our radicand, so we multiply our radicand together. So we have the cube root, okay, like whatever we have earlier, and this is 2 times 5, so we have cube root of 10. The index has to be same if you are multiplying. Similarly, if we have a quotient, okay, with a index same, so we have index n, then you can multiply, then you can divide this radicand. Let's say we have the square root of 10 divided by square root of 2. Okay, so in both of these, this is the square root index 2, this is the square root index 2, so we have a same index, and in this case we have square root of 10 divided by 2, so we have square root 10 divided by 2 is equals to 5. The index has to be same when you are multiplying or whenever you are dividing. Okay, the next property is that, so we have nth root of a to the power m, so it is same as mth power of nth root of a. Okay, so you can rewrite this example. So we have square root of, let's say, okay, let's say we have cube root of x square. Now this is same as square of cube root of x. It's the same thing. Okay, now let's do some example. So we have the square root of -5 square. Now this is the even index, right? The index for this one is 2, so our index is 2 here, so we have the even index. And if we have the even index, using our very first property, see our first property, if the n is even, then nth root of a to the power n is absolute value of a. So this is equals to absolute value of -5, and we can cancel here. Since the index and the exponent is same, we can cancel, and the absolute value of -5 is +5. Now number b, we have the cube root of -5 cube. The index is odd, so see here the index is odd, they are equal, we can cancel. Okay, we can cancel, but the index is odd, so this is equals to -5. So if it's even, make sure to have absolute value. If it's odd, you are not required to have absolute value. Okay, in number c, we have a 2 radical expression and we need to multiply. So we have 4th root of 4 and 4th root of 5, and whenever you are multiplying, the only thing that you're going to check is the index. The index has to be same, then only you can multiply radicand together. So this is equals to, you have a 4th root of 4 times 5, which are the radicand, which is equals to, we have the 4th root 4 times 5 is 20. So make sure to have a same index, to check same index when you are multiplying. Okay, in number d, we have square root of 50 and we want to rewrite this. Okay, now 50, what is 50 equals to? Let's use our tree diagram to write down 50 as a prime factor. So we have a 50, so the smallest prime number that divide 50 is 2, so 2 divided 50, that is 25. The smallest prime number that divides 25 is 5. 5 divided 25 is 5. So we can rewrite 50 as a 2 times 5 times 5, which is 5 square. Okay, so here we have square root 2 times 5 square. Okay, now since the radicand, they are in a product form, so we have this radicand, we have this factor, we have our radicand in a factor form, so we can rewrite this as a square root of 2 times square root of 5 squared. Okay, so this is the other way of our property number 3. So here in property 3, so this is what we have. Okay, nth root of ab. Okay, these two are in a product form, a b are in a product form, so we can separate it. Okay, so we have nth root of a times nth root of b, so we use property 3 here. Now, so for the first radical expression, the index of this radical expression is 2, the exponent of 2 is 1. Okay, for the second, the index is 2, the exponent is 2. If we have the same index and a same exponent, we can cancel. So we can cancel this square root and this exponent. But for the first radical expression, index and exponent are not same, so it remains as it is. So we have square root of 2 times 5, and you can write 5 in the front. So this is 5 square root of 2 is our final answer. Okay, so we have next number E. We have the square root of 72, and we have square divided by square root of 2. Now here the index of our square root of 72 is 2, right? Similarly, the index is 2, and the index for the square root of 2 is also 2. So we have the same index. So if we have the same index, then we can rewrite this as the square root of 72 divided by 2. So we have square root 72 divided by 2 is 36, and the square root of 36 is 6 square. We have an even index. If it's even index, then we have absolute value of 6. You can cancel this and this, because index is same as your exponent, and absolute value of 6 is equals to 6 is our final answer. Now here we have cube root of 8 to the power 5. Okay, so what do we know about 8? So we can rewrite 8 as a 2 cube. Okay, and we have 5 power as it is. Okay, now so here this 3 and 5, we can switch this. Okay, we can switch the place, because 3 times 5 is same as 5 times 3. So this is cube root of 2 to the power 5 to the power cube. These two are same thing. Now we have a odd index, and the index is equals to the exponent, so you can cancel the cube root and the cube power. We are left with 2 to the power 5, and 2 to the power 5 is 2 times 2 times 2 times 2 times 2, which is 32. The next we have 216 x to the power 5 y to the power cube. Now what is 216 equals to? Let's try to rewrite 216 equals to. Now is our 216 square of some number, or is there any way we can rewrite 216? So what is 216 equals to? Okay, if you have a confusion, then yeah, you can always use a tree diagram. Okay, so let's start from tree diagram. So we have 216. Now we find the smallest prime number that divides 216, which is 2. 2 divided by 160, 216 is should be 108, right? Now 108, we can still use 2 divided by 2 divided 108 is 54. Okay, we can divide 54 by 2 divided 54 is 27. 27 is 3 divided 27 is 9, and 9 is 3 times 3. So 216 is, so we have 2 times 2 is 2, which is 2 square, time 2 time you have 3 times 3, which is 3 square time 3. So our 216 is 2 square time 2 time 3 square time 3. Now what about x to the power 5? How can we rewrite x to the power 5? So we have x to the power 5, and x to the power 5 is x time x time x time x time x. The index is 2. So let's make a pair of 2. So we have x time x, x time x. So x time x is x square, x time x is x square time x. So we have x squared time x squared time x, and y cube is y squared time y. Okay, and the reason we are having exponent 2 is because index is 2. So if you have index 2, you express as exponent of 2 so that you can cancel your radical sign and the exponent. If you have index 3, you're gonna rewrite it as exponent of 3. Okay, now so here every every radicand are in a factor form. Okay, see, factor form is all of these are in a product form. So if all of these are in a product form, then what we can do is that we can rewrite all of these using separate radical sign. Okay, you can do that. Or now what we look here is that we look for the radicand having exponent same as the index. Now here this radicand has an exponent which is same as the index 2, right? Okay, this has a exponent same as the index, this has exponent same as index, this has exponent same as index, this has exponent same as index. Now we take all these factor having exponent same as index outside the radical sign. So we write down outside the radical sign. So we write down this 2, we write down this 3 times 3, we write down this x times x, we write down this x times x, we write down this y times y outside the radical sign. And the factor that do not have exponent same as the index 2 3 x y, it stays inside the radical sign. So we have 2 times 3 times x times y. Now if we simplify, 2 times 3 is 6, x times x is x square times y is y square root. 2 times 3 is 6, x times y is xy, and this is our final answer. Okay, so the key thing here is that if you have a factor under the radical sign, okay, with the exponent same as the index, then you can write down that factor outside the radical sign without exponent. Okay, and every factor that does not have exponent same as the index, it stays under the radical sign. Okay, now let's see here number G. So here we have square root of, so we have square root x square, we have 16 is 4 square, right? Excuse me. Now here the numerator has a exponent 2, denominator has exponent 2, and our index is 2. So what we can do is that we can write x over 4 outside the radical sign. Okay, so the exponent has to be the same as the index in order to write outside the radical sign. Okay, the next here we have rationalizing denominators. Okay, rationalizing denominators means we have a rational expression. Okay, and that rational expression has a irrational denominator. So if we have an expression with a irrational denominator, converting that irrational denominator into a rational denominator is a rationalization. Here what I mean, for example, if we have 1 over root 2, so let me take a rational radical expression. So we have 2 over square root of 3. Now here this is our denominator and this square root of 3 is irrational number. Okay, so we have to convert this irrational denominator into a rational denominator, and that is a rationalization. So every time if you are asked to rationalize, then you are converting irrational denominator into a rational denominator. Okay, now before that, so here we have a pair of form. So we have a square root of b plus c square root of d and a square root of b minus c square root of d. The only difference that we have in between these two expressions is that the sign of the second expression is opposite. So we have positive, we have negative. Okay, you have the same expression, the only difference is that the sign in between those two expression is different. One is positive, other is negative. Then these two expressions are called the conjugates. Okay, and if we multiply the conjugates together, then we can get rid of radical sign. So here let me take, we have 1 positive square root of 2. Okay, so this is my radical expression, and the other radical expression is I have 1 minus square root of 2. The only difference in between these two radical expression is one is positive, okay, and we have, in the other one we have negative. That's the only difference, the remaining is same. If this is the case, then these two are conjugates. Okay, so these two are conjugates, and if we multiply the conjugates together, we get rid of radical symbol. Okay, let's see the product of these two number. So we have 1 plus root 2 time 1 minus root 2. So here we have a two terms, right? We have a two terms, that is we have a binomial times binomial, and if we have a binomial times binomial, we use FOIL. Okay, so our first term, so this is our first term. So let's multiply first term, 1 times 1, that is 1. Then we look for the outside term. Okay, so let me erase this one. So we have the outside terms 1 and negative root 2. So 1 times negative root 2 is negative root 2. Now we multiply the inside terms. So we have square root of 2 and 1. This is inside term, and which is positive square root of 2 times positive 1, that is positive square root of 2. And at the end we multiply last term. So our last terms are square root of 2 times negative square root of 2. So this is positive times negative, that is negative, and square root of 2 times square root of 2, that is square root of 2 then square, right? We have a same number 2 times. Now this is, so here, so if we see first, if we do middle two expression, if we see here, these two are like terms. Okay, and to be like terms, here the index has to be same. The index of this expression is 2, the index of the third expression is 2, the index is same, and the radicand is same. The radicand is 2, radicand is 2. So if the index is same and the radicand is same, then these terms are like terms, and if you have a like terms, you can add, you can subtract. Okay, Okay, so here, since these two are like terms, we can do addition and a subtraction. So we have a same number with opposite sign, so these two cancel and these two are equals to 0, so this cancel and equals to 0. In the last expression, the index is 2 and the exponent is 2, so we can cancel these two. So this is 1 minus 2, we get minus 1. Initially, what we had two radical expression. We had the conjugate pair, and when we multiply conjugate pair, we get a number which is a rational. Okay, so if you want to get rid of the irrational number, you multiply the irrational number by its conjugate. Okay, now so let's go back to our previous example. So this example, so we have 2 over root 3, and we want to get rid of this radicals number in the denominator. Okay, now how can we get rid of radical sign in the denominator? So for this one, so if you have a single one term radical expression, then if you multiply a term by the same term, we get rid of radical sign. For example, you have a square root of 3, and if you multiply square root of 3 by square root of 3, we get 3, right? So we multiply here by square root of 3 in the numerator and denominator, and the reason is that we want to make our denominator as a rational number. So this is 2 times root 3, that is 2 root 3, and root 3 times root 3 is root 3 square. So you can cancel square and square root. So we are left with 2 square root of 3 divided by 3, and this is our final answer. Okay, here initially we had square root of 3 as a denominator, which is an irrational number, and at the end we have 3, which is a rational number. Okay, this both of these expressions are same. This number, okay, so this number and the number that we have at the end, these two are the same number. The only difference is that the first expression has a irrational denominator and the second expression has rational denominator. Okay, so rationalization means you are converting the irrational denominator into a rational denominator. And we'll be doing this a lot as we start our chapter, the real chapter. We'll be doing all this again. Okay, now the next here is that rational exponent. So if we have a rational exponent, so rational exponent means we have a we have an exponent as a rational number, as a fraction. So let's take, we have 2 to the power 3 over 4. So our exponent is 3 over 4. This is a fraction. Okay, so if you have a rational exponent, if you have a fraction as exponent, then the denominator of that rational number is the index for the radical. Okay, now we can rewrite 2 to the power 3 over 4 as this denominator is the index. Okay, so we are writing using a radical sign. So we have the radical sign, the denominator 4 is the index, and whatever you have remaining is radicand. 2 to the power 3 is the radicand. These two are the same thing. Okay, one more. So if you have 2 to the power 1/2, so you have the fraction. So you have here the fraction, so this is 1 over 2 as a exponent. So you have this fraction as exponent. If this is the case, then your denominator, so this is your index. If you want to rewrite using a radical sign, so you have a radical sign, the denominator, this 2 is the index, okay, and the remaining 2 to the power numerator is our radicand. And since it's a index 2, so you are not required to write index 2 every time. So this is simply square root of 2 to the power 1 is 2. Okay, or you can go other way. Okay, so if you have the radical expression, okay, let's say you have a fifth root of 2 to the power 3, then you can rewrite this expression without radical sign, and in that case your index will be the denominator for this exponent. So this is 2 to the power 3 over 5. so your index is the denominator. Okay, now let's do some example here. So here it tells us to convert to radical notation, so we need to rewrite using a radical sign. So if we are rewriting using a radical sign, we're gonna have a radical sign. Now what is the index here? The index is the denominator of the exponent, okay, which is 4. So 4 is the index, and the remaining, so we are left with 7 to the power 3. So this is our radicand. 7 to the power 3 is the radicand. Okay, so next here we have 8 to the power negative 5 over 3. So let me rewrite this as 8 to the power negative 5 over 3. Okay, we are writing using a radical sign, so we're gonna have radical sign. Now what is the index? The denominator of exponent. So this is the denominator, so this is your index, and the remaining is your radicand. So this remaining 8 to the power negative 5 is the radicand. Similarly for number C, so we have m to the power 1 over 6. Okay, we're gonna rewrite using radical sign. So we have a radical sign, the index is the denominator, so this is our denominator, so our index is 6, and the remaining m to the power 1 is the radicand, m to the power 1. So we have 6th root of m to the power 1 is simply m, and this is our final answer. Okay, and the last example for this one is, so we have negative 32 to the power 2 over 5. So let's rewrite using radical sign. So this is same as negative 32 to the power 2 over 5. So same thing, right? And let's rewrite. So we have a radical sign. What will be the index? The index is the denominator, which is 5, and the remaining, which is negative 32 to the power 2, is our radicand. So we have negative 32 to the power 2. Okay, so this is how we can rewrite the expression with a rational exponent using a radical sign. Okay, so let's do this much for today. In next video we will be talking about our very first chapter. If you have any question, don't hesitate to write me an email or give me a call. Thank you. I'll see you in next video.